Let me first welcome you here. This is our first live demo session for Bridgecrew. My name is Guy Eisenkot. I am a co-founder and also the VP of Product here at Bridgecrew. The purpose of today's session is to demonstrate some of our core features running Bridgecrew, and we will be demonstrating some of the amazing features we have to help you get started securing your public cloud infrastructure and providing you the very best guidance on getting started with the platform. In case you're unfamiliar with Bridgecrew, we are a cloud security platform that's aimed for a developer mindset. We'll also be sending out this recording after this is all said and done. So feel free to sit back, pay attention, and definitely, since this is a live demonstration, feel free to shoot your questions on top of our Zoom chat, and I'll be happy to stop at any time and zoom in on any of the features we've got to show you today. So today's session is essentially a demonstration session. It'll be structured very similar to how it is to get started with our platform. We'll walk through some of the basics of getting started, how to sign up, how to onboard your first cloud and code accounts, and how to get familiar with some of the core functionality of our policy as code engine. So again, this is definitely meant to be an interactive session, so feel free to barge in and stop me at any time using your using the chat, and I'll make coincidental stops at a few key locations to make sure that you're all and we're all on the same page. So with that, let's actually get started. So you can see the Bridgecrew website on the screen that I'm sharing with you right now. And I think the most important thing that you need to know about Bridgecrew coming in is that what we've done for the past 2 years is we've built in all the visibility and governance control you will essentially need to get you started in implementing security and compliance best practices in the public cloud. We utilize a principle of technology called policy as code. And what that means is that we write and execute a variety of security and compliance policies, as you may think, in code. And this becomes extremely powerful when trying to essentially onboard additional technologies and cloud providers and cloud services at a high rate. And in the same time, continuing to keep up with the pace of a rapidly growing and obviously high scale environment as we have in cloud. So the nice thing about the platform, it's completely self-service. Oh, and you can't see the screen. Okay, let's make sure you can see. Give me one more sec. How's that? Chat verse. Perfect. Awesome. So as we get started, I was just about to say the platform, just like many other developer first or developer centric technologies, is a SaaS platform. It's completely self-service, which means you can come into our website and start working on the Bridgecrew platform at all time by simply selecting the sign up flow, and we'll start working up that in a sec. We also have some interesting open source projects you should definitely check out. So if you're interested in some of those, definitely check out our GitHub repo and pay that attention. So let's get started. Why shall we? So we start with signing up. So signing up to the platform couldn't be easier. You can use a GitHub or a Google single sign-on. You can use your email or any work email or personal email to get started. And from that point forward, we'll essentially guide you through our onboarding process. And Bridgecrew works great in a couple of different form factors, and we'll talk about those in a second. The first one is connecting Bridgecrew to your public cloud accounts. And this is probably core value, and this is probably where 99% of our existing customer base will start off. You have an AWS account. You know that you have developers that are constantly increasing your footprint in the public cloud, building your web applications and adding more and more cloud services. But you're lacking the best practices and the controls to identify what's really going on. So as I mentioned, one of the first things that you can do with the platform is tap it into your Amazon Web Service, your Google Cloud Platform, or your Microsoft Azure subscription, and simply using a quick install, start to read out configuration directly from that cloud and assess them against robust baselines for security and compliance that are built on top of our policies code engine. Installation couldn't be simpler. We essentially point and click to our select cloud providers. You can actually use more than one. With AWS, it's a simple CloudFormation template. I can simply click Launch Stack, and this redirects me to my AWS console, where I'll be prompted to install a read-only template. And what this does, it installs Bridgecrew with a read-only role that Bridgecrew can essentially assume using cross-account access and start to evaluate configurations in your public cloud. One super important thing to note is that Bridgecrew only focuses, and you can read this from, from the template YAML, only on configuration metadata. Bridgecrew will never require to see your actual data stored in your buckets or your databases, but only the metadata that's used to configure them. We'll continuously pull that data using AWS APIs, mindful of rate limits, and we'll continuously evaluate them against a continuously growing baseline of the previous configurations, but also against a robust variety of policies that we have built out the box, and we'll touch those later down the line. The deployment, again, is simply a CloudFormation installation. I select to acknowledge that this CloudFormation will create IAM resources on my behalf. And when I click Create Stack, it essentially starts building up the new stack. When I go back to the platform, I'll start to see my incidents pile up. So incidents essentially are verified misconfigurations in my public cloud, and we'll explore those in a second. We can also connect Bridgecrew to code repositories and a variety of CI/CD systems. Bridgecrew essentially will tap into any one of those points in your infrastructure provisioning process and pull out infrastructure as code files that describe or declare your infrastructure in common configuration languages like Kubernetes or Terraform or CloudFormation or serverless framework, or you name it. Will assess the construct of dependencies within that repository and essentially begin to evaluate those infrastructure as code templates using the same policies we use to evaluate your public cloud. We view this approach where we take both cloud provider information and code base infrastructure as code and cross-reference those together to be the best combination to ensure that infrastructure is staying secure in runtime, but also we're implementing preventive controls during build time. And this is what this demonstration is going to be all about. One small addition to that is you'll recognize the Kubernetes icon here. We can also deploy that same policy framework for running Kubernetes clusters, as well as the YAMLs that define them in CI/CD. Integrating to a CI/CD couldn't be simpler. Again, we use the native authorization of each and every CI provider as an example. So for a version control system like GitHub, for example, will essentially authorize through the marketplace, provide GitHub the required permissions to view repositories that contain infrastructure as code. And once those are granted, I'm able to select the repositories that essentially contain my infrastructure as code files. And again, within a matter of minutes, that telemetry is picked up, that repo structure, those infrastructure as code files. We read all that together, rake it in, and evaluate it all against a single compliance policy as code frame. Okay, any questions so far? Excellent. If you do, please leave them on the chat. You can see additional integrations we have here laid on the bottom. We have a Slack integration that can send out error notifications into a dedicated Slack channel. We have a dedicated two-way integrations into Jira that can enable you to open Jira tickets to resolve some of the issues that you find in runtime and in build time. And we also have a Splunk push mechanism that enables us to push out events to notify our security or SOC team when misconfigurations are found over time. Let's stroll into incidents. That's where most of us spend most of our time. This is obviously the most powerful investigation work surface for a DevOps professional that wants to start evaluating resources in the environment. You'll see here, I have all my policies laid out on the left. These are out-of-the-box policies that are defined based on common industry regulations or specific best practices that are laid down either by the cloud providers themselves, governing bodies like the Cloud Security Institution, and also by a variety of consultants that we work with, together with a community of builders that help us continuously evaluate new upcoming services and their usage and keep these policies up to date. Each and every one of these policies essentially is scanned at least twice a day against all of the configurations, that we raked in through that polling process from running cloud providers and from CI/CD systems and version control systems. So these are all the policies we have currently lined out here on my left. In my central view, you'll be able to see both Terraform files indicated by the Terraform logo up here, and also a variety of other logos like the AWS logo or even the CloudFormation logo. And the reason you're seeing all of these together is because, as I mentioned, Bridgecrew assessed each and every one of these resources using the same type of backend infrastructure and essentially applied policy onto all of them. So when it found a misconfiguration in runtime, for example, on an AWS account, it pulled out all of the telemetry that's associated to that specific resource, and all of the telemetry that's associated to that resource from an infrastructure as code or a Terraform file, and brought that all together into one screen. So as an operator, I don't only see the misconfigured resource in my cloud provider that I can potentially fix, and that fix could essentially get overrun by my next nightly job that deploys my infrastructure as code. It essentially brings in the context of an infrastructure as code file that's used to provision that bucket. You'll be able to find some of these correlations here in this list. What's interesting also here is the fact that this is working after the fact. Remember that. So we have infrastructure as code that was either deployed or merged into a master branch where we pulled out all of these files. Now we're at the point where we can start responding and to fix some of these issues. And we actually landed on a very popular policy, which is enforcing encryption on an S3 bucket. And there's a variety of ways to do that. We even outline some of them as part of our guidelines. So when I navigated to my guideline, you can see we have descriptions and rationale for each policy, scripted very similarly to the ones you'll find on a CIS benchmark or one of your favorite compliance regulations. But we also list out all of the remediation steps you can do in order to counteract and essentially fix these resources. These are step-by-step instructions, playbooked scripts, or infrastructure as code that identifies and show you how you can fix these misconfigurations. So we have a playbook that can essentially invoke an S3 a Lambda function and essentially apply encryption on a running bucket. And here at the bottom, I have manual remediation steps where I can go into AWS, into S3 console, select specific repos, and start to apply encryption using my favorite encryption key one by one. Last, I have CLI commands as well, which I can utilize AWS CLI in order to do that. And even here at the bottom, I have Terraform and CloudFormation examples where I can see how proper encryption to S3 buckets should look like. So all of this information, even before I start to explore my misconfigured resources. When I go to my errors tab, again, you can see I have multiple types of errors here, mostly associated with Terraform files and AWS resources. When I click into one of them, I'm navigated into a resource explorer. And I think the resource explorer is a super interesting concept because resources, in many cases, are not something that are long-lived, right? Essentially, if we use infrastructure as code, we expect our resources to be immutable, and sometimes we even override them from time to time. But what we forget is that resources essentially have a history. They have a story to tell. They have resources that they affect themselves, resources that they're affected by. That's why for Bridgecrew, resource is actually a very core and essential component of how we view infrastructure. And for that, what we essentially do is we run every element in an environment that's running through the same type of codification process. What that means is that instead of just taking out what the AWS API provides us, we're actually asking a variety of additional questions about how this resource is configured. We portray that resource information in a very common construct, which is Terraform, a language used to provision probably most of the infrastructure as code in the world today. And we take all that information and we index it in order to apply additional, more advanced policy. So here up top, you can see some of the metadata that we are able to fetch out, including, is this bucket using versioning? Is it, what type of bucket is it? Does it have a force destroy conversion in play? And also, for some resources, we're even able to extract the modification history. What I can do with a bucket that's already running, I can essentially remediate it using our existing auto remediation functions. We've built out, and I showed you this a second ago, a remediation lambda that can go into AWS and actually revert the configuration or add the configuration that's missing for an existing resource. So when I click on AWS, I can either go to console and remediate it using the remediation steps, but I can also remediate directly through the platform. And through the platform, I have playbooks. In this case, a playbook that will add an AES 256 encryption address to this policy's configuration manifest. And I can do the same for all of the S3 buckets that I have in running in this environment. So essentially, if I have 4, 5, 6 of these buckets, I can swipe them all and remediate them all in one single click. For infrastructure as code, it really gets interesting because instead of just evaluating the code and essentially fixing it in runtime, I can actually provide an actionable fix that a developer can pick up as a pull request as part of their native infrastructure provisioning process. You can see that from an S3 bucket data template file that we extracted, in this case from GitHub, I was able to extract the same type of information and to build a very similar metadata construct. And also, in this case, I have the raw Terraform. I don't need to even make the conversion. For Terraform, you can see Bridgecrew also calculated what type of fix should be added and actually suggested it already in code. So you can see inline in how this bucket is already portrayed in my Git repo, I have inline recommendation of how to fix it. And with the addition of what specific error I'm currently handling. You can see this is a widely demoed environment. We have a few fix pull requests that were created in the past, but we also have the initial scan. The first time that this specific file was found, and essentially the entire history of issues it had when we first saw it. Some of these already are still existing, and some of them were already resolved. So this history is super vital for me as a DevOps operator or as someone from the infrastructure team that wants to zoom in and to look into fixing this resource. So how do I fix it? It couldn't be simpler. I click the small checkbox here on the left, click remediate, and together with my existing resource S3 bucket that I wanted to remediate from before, I now have the option to open a fix pull request in GitHub that will essentially fix and add the additional missing attributes into this file. Pretty cool. And I can do the same for all of those Terraform files that you saw in the list. I can even do them for the CloudFormation file we saw before. So all of this context and essentially code-based fixes are applicable for this policy. This is not applicable for all policies, but whenever we see very straightforward configurations that have either a mandatory or a commonly recognized fix, we recommend to add them. So these are policy violations. You can see I have a couple hundreds of them in a fairly large environment that has GCP information, Azure information, AWS information. So don't get alarmed by that. It's really one of our more polluted, you would say, environment. But you can see the path to fixing these issues is very simple. The next thing I want to show you, unless there's any questions, taking a quick look at the chat now. Beautiful. The next thing I want to show you is our policies view. And the reason I want to show you the policies view is because I want to let you see the underlying infrastructure that goes into powering all of those findings you saw before. So this policy dashboard essentially pulls in all of those policies that we have running against the various cloud providers, the various configuration frameworks, and all of those are crunching those configurations, as I told you, on a scheduled basis and identifying new misconfigured code. You can see we have complete summaries for each and every one of these configurations, as well as quick links to our documentation, which is actually fully publicly available. And you are more than welcome, if you're using the platform or not, to explore them and explore ways where you can already fix infrastructure that's misconfigured in your environment. So feel free to take a look at that. You can also export a auditor-friendly an auditor-friendly compliance report that sits on top of commonly renowned industry benchmarks. So for example, I've selected an AWS account coupled with a NIST 853 report. And when I PDF export, I'll get a PDF that is essentially breaking down the individual section within NIST 853 that apply to my environment. I'll see only the controls that are relevant to my environment with a summary based on severity and a passing versus failing annex of all of the policies that were evaluated. You can see these are all translated into NIST 853 policies and procedures and individual sections. As requested by most auditors, we also include suppressions and fail checks and separate annexes, which are also exported and can be used to pass over to an auditor. So check out compliance exports. One other additional way to make sure that our repositories are in good shape is to add Readme badges. This is actually a very recent addition to the platform, where you can select a repository that Bridgecrew is running, has to be a public repository, and has to be on GitHub for now, and essentially paste in a markdown badge that contains the latest scan results for your infrastructure. So you can see we have a vulnerable by design, actually, repository that we call TerraGo. Check it out. Very popular project that we've contributed. And you can see it has 118 errors in total and a variety of failures across known benchmarks. I can select these, paste them into my repository, and every day when I go into my repository on GitHub, check it out, and want to see where it's at, I'll be able to know if anyone has inserted any other misconfigurations into it. What I really want to show you now is custom policies. Custom policies is probably been the #1 asked functionality from us from the moment we started to collect this type of information, weld it into a single data model, and also to build it out into a single construct that enables people to write a single policy. And you'll find this policy construction framework to be the simplest one you've ever seen, just for the fact that it's really a point and click. You don't have to know anything about compliance or anything about Terraform. All you need to know is what type of policy you want to enforce. Let's maybe start with something like an RDS sample policy to restrict public access. So if you're not familiar, RDS is essentially databases hosted on AWS, a very common service you could use to run MySQL databases on your AWS accounts. I can provide full guidelines into what I want my developers to do when they encounter this policy. I can provide it various levels of severity, and I can even attach it to a category and a benchmark to coincide with my additional reporting. What I'll have to do next in order to make this an effective policy is to select a cloud provider. You can see we support all 3 cloud providers and almost 12,000 individual resource types across all 3 providers. In AWS, I'll select RDS. So this is a DB instance. And I'll click definition. And this is where it gets interesting. So you saw I didn't mention this right part of the screen. This is actually an interactive preview page that will query in real time the graph database that sits behind Bridgecrew's policy as code. What will happen is I'll define a set of parameters that define what types of behaviors I want my RDS instances to comply by. Based on that, a preview will be generated, and I'll be actually able to see if there's any resources that are currently violating this new policy that I'm planning to build. Let's take something simple. For example, let's see if resources have a backup retention period. So I'll select backup retention period. I'll see if that exists. And in the background, I'll have resources that are going to be evaluated against this baseline. And you can see there's no violating resources for this because I passed every one of my configurations in this case. Now I'll select publicly accessible. And what I'm looking for now is resources that are defined in my environment and contain the publicly accessible clause. If I look for publicly accessible equal true, so if I look for publicly accessible does not equal true, meaning false, you can see that I got two new Terraform instances in this case that define a vulnerable by design RDS instance. And you can see a variety of configurations there here, including the publicly accessible config. And you can see I can play around and add and subtract either using the or the or operator, and essentially meld in and play around with it to create my optimal configuration for an RDS instance. So I can make sure that it's using only the instance classes that I recommend. It's only when I want it to be public or not. I can have it have its own backup configurations. All of that can be defined through this one RDS sample policy. And what will happen whenever this policy runs is that it will identify when this type of configuration is merged into my main branch, or in a worst case, already pushed into my cloud. Pretty cool. So I see we have a question from the forum. I'll read it out loud. Are all of the misconfigurations detected both in build time or runtime? Question number one. So the answer is yes. If a configuration can be modified, it can be changed, it can be tweaked by the end user, then we will evaluate it in both build time and runtime. This is true for almost all of the resources we cover. There are obvious exceptions in very unique or new types of resources, but essentially for all the popular services across the three cloud providers, it's the same type of misconfigurations. Remainder of the question is, are there some kind of misconfigurations that can just be detected in runtime? How can we detect IAC misconfigurations in runtime? Just scanning the cloud. So this is essentially where we try to simplify things. If you want to apply the same configuration for your build time resources and your runtime resources, you should definitely go ahead and use the policy builder, compile all of those together, and query them from a single point in a single location. If you want to be able to query, or not to query, but to enforce a policy only on a subset of resources, specifically in infrastructure as code, that's actually an advanced option we also enable. You'll essentially be able to build out your policies as part of a remote directory that's hosted on your GitHub repo, and direct our continuous scanner to look only at that specific configuration. I'll be happy to include the documentation for that process to get you started, but that's definitely an advanced property to enable. Sweet. We'll take one more minute to see if there's any other questions from the forum. Great. So let me discard this policy. And now, since we only have about 10 minutes left, I want to shift the focus. Up until now, I showed you what it's like to sit on the captain's chair and to actually operate policy as code, respond to misconfigurations, and essentially to enforce new types of controls over time. Now, I want you to take you to the other side of that story. What happens if I have a development team inside my organization, and myself as a DevOps or an infrastructure security professional want to enforce security and compliance best practices into the infrastructure that they will provision using infrastructure as code? And this is where preventive policy as code comes into place, and I think it's very exciting. Let me pivot into a GitHub instance to show you how that looks. So I have a, a public GitHub repo called Try Bridgecrew, and it contains TerraGoat. And I've mentioned TerraGoat before. This is the fork of the original TerraGoat. And TerraGoat, just like 3 of its sister repositories, is a repository that contains bad configurations. So bad configurations by design. And we've built this as an educational tool for people who are implementing policy as code for the first time, that are kicking the tires with Bridgecrew or open source projects, and are trying out various ways to identify misconfigured resources. TerraGoat, as you saw before, has over 100 misconfigured resources in it. So I feel pretty comfortable in adding a few more in there. And what I've done for the purpose of this exercise is I've actually Googled some of the most popular types of AWS services. I've Googled something like a EC2 instance, ended up on a very popular open source repository that contains configuration manifests. I found a CloudFront distribution for an S3 bucket that is recommended for use using obviously some additional configurations on top of it. And to make things worse, I've actually taken a very bad, very basic configuration of Kubernetes, of a Kubernetes pod with 0 of the default configurations you should probably use when configuring Kubernetes. And I'm taking these bad configurations by design because I want to show you how a preventive approach looks like from my eyes as a junior developer. And it's not because I have harmful intent. I'm actually building cloud resources maybe for the first time, and I want to be able essentially to get a very quick feedback loop on the actions that I'm taking in this project. So I'm going to manually upload these files from my local directory. This will take just a minute. And I'll submit them into a new side branch, something like my new feature branch with infrastructure as code. So I'm going to propose the change, and I'm actually going to go ahead and open a pull request. I know this would probably not necessarily represent how code gets all the way into the main branch, but just for the sake of it, I want to show you what happens when Bridgecrew identifies this. So when I created a new branch with these new infrastructure as code files. What really happened is Bridgecrew fetched all of these configurations in real time. You can see that in a mere matter of seconds, we kicked off an automated action that scanned these pull requests. And a few seconds later, before we even were able to assign additional reviewers, the Bridgecrew bot popped up. And what essentially happened here is all of these new infrastructure as code files got sent into my Bridgecrew platform that's already scanning this repo's main branch and evaluated them against those popular security and compliance best practices that I showed you before. And when it evaluated them the same way as it would have evaluated my main branch, it identified misconfigurations, some in my S3 buckets, some in my YAML files, but it did something else. It also provided me additional information for investigating and troubleshooting these misconfigurations. So let's see what we have here. We see the first comment is essentially Bridgecrew scanned 3 files and found almost 30 misconfigured individual arguments, so 28 infrastructure configuration errors. And all of these get a special annotation. Each one of them gets a name of the error that was found, a link back to the guideline that we saw before in the platform, a severity level, usually determined by a governing body like the CIS or by the cloud providers themselves, but also a more strict annotation into the specific area in the code, either into the specific line or a range of lines that define the area where the misconfiguration was identified. So you can see for my S3 bucket with a website purpose with a CloudFront distribution in front of it, it found that it was missing logging. It had public ACLs. It didn't block public ACLs. It didn't have a public block policy. Didn't have encryption and rest that we saw before. And you can see that if I scroll down, I find my Kubernetes misconfiguration. So a bunch of the basic limitations you should already be using, things like not giving additional permissions to your pods, the memory limits configuration that's missing, the memory request configuration that's missing, probably the kube dashboard exposed here somewhere, file system read only, all of those popping up in here. So this is super useful. Think of me again in the eyes of someone who's provisioning resources for the first time. Before I even pushed things into my CI system, I was able to get all of this feedback very quickly. And not only was I able to get all of this feedback very quickly, I also got a direct link into how to solve some of these. So when I click a guideline, I'm able to review the Bridgecrew guidelines for how to resolve some of these misconfigurations. So for the readiness pod to be configured, I have the exact configuration I should be using right here, as well as the description, the rationale, and everything that we saw before. Cool. See, we have one question in the chat. So can Bridgecrew block developers from deploying? What a timely question. So the answer is absolutely yes. We don't like to think of us as people that are blocking developers from deploying, but rather laying in some of the guardrails that can be used in order to make sure that only the proper configuration is inserted into the platform. And this is a good point maybe to talk a little bit about some of our more popular integrations. So obviously the top types of integrations that we see are with obviously the popular cloud providers, AWS, GCP, and Azure. But we also integrate into all of the popular version control systems, both their SaaS and their on-prem versions. And when you deploy Bridgecrew against each and every one of these version control systems, essentially Bridgecrew will annotate every new pull request on the repos that it's monitoring. So developers would essentially initially be able to see those annotations and decide, under their discretion whether to push it or not. If you want to block a misconfiguration as part of a CI process, that's where our CI/CD integrations come into play. And you can see we have a few of those very popular integrations like Circle CI, GitHub Actions, AWS Code Build, Jenkins. We have a few others. The GitLab Runner is documented on our website, on our documentation page, and Azure repos, which is getting tons of traction recently. So all of this essentially can be defined using a standard YAML file that most of these systems are using, and you can actually define it to essentially hard fail any build that contains a misconfiguration that's found by the Bridgecrew scanner. And if you're interested about that, go to bridgecrew.io/docs and docs.bridgecrew.io and navigate to the continuous integration tab, and you'll find all the ways to block block developers from building misconfigured infrastructure. Cool. I think we only have 4 minutes left, so time for maybe one last question. And if not, I really have one final surprise to show. So I'm seeing one more question from Paul, asking if we have a source control integration with Azure DevOps. So the answer is not yet. That specific integration is in the works, so follow the Bridgecrew changelog for an update on that very soon. Sweet. So with 3 minutes to go, I want to show you one last surprise. And this is another interesting addition we had to the platform very recently. And we call these insights. So up until now, we looked at violations. So violations are very strict rules essentially that we apply on infrastructure based on predefined configurations. Insights are a variety of engines that we apply against the configurations that we found using that graph database in order to identify outlier configurations that could potentially become a risk. One of those insights is excessive permissions. And what the excessive permissions engine does is it looks at configuration used by your existing IAM roles, users, policies, and groups, evaluates them against actual usage data. We take use of information you already gathered using the AWS IAM API and a service called Access Advisor. And when we identify a mismatch, when for example, an IAM role is entitled to use a service that wasn't used in the last 90 days, will essentially compute a right-sized document you can replace and use instead of that. And let me show you how an example of that looks like. You can see in this case, we have an IAM role that was recently evaluated. And it contains originally tens of action permissions for elastic load balancing in a couple of different varieties, to the WAF, to the Shield service, a bunch of these services. You can see none of them were actually being used. So what the IAM Insight engine essentially did, it identifies all of those misused credentials, and I can actually go to AWS console and investigate to see that raw information, and removed it and provided me with a right-sized JSON statement I can take back into my AWS IAM policy and replace it. And none of the existing functionality that was used in the last 90 days will be impacted, and the additional permissions required will all be there based on the usage attributes as well. So if you're interested in IAM Insights, check out our documentation as well as the changelog insert about that. And I think that's all the time we have for today. So unless there's like one last question that I'd love to have, that's all the time we have for a demo now. Awesome. So let me thank you for joining us today and participating and asking these great questions. We'll be sending out this recording soon if you want to share it with your peers and colleagues. Check out bridgecrew.io for sign-up information and our documentation to learn more about the Bridgecrew platform capabilities. And we hope to see you very soon, either using the platform or participating in one of our next live demo occasions. Bye.